Traffic signal poles are made of high-strength steel. Years of weather exposure can cause corrosion, so the poles are galvanized on both sides for protection. Each pole has a welded plate to connect it to a perpendicular pole. The poles are made out of these steel sheets. The steel arrives at the factory in one large roll. They use a decoiler to unwind the sheet and flatten it out. Then a shear cuts it to the correct length. A computer-guided plasma cutter marks short lines on both ends of the sheet. These lines indicate where to bend the flat sheet to form a round pole. The machine cuts the sheet into a rectangular shape or a trapezoid shape if the pole will taper at the top. Workers number the machine lines with chalk, giving lines directly opposite of each other the same number. Then they transfer the sheet to a bending machine called a press brake. The press brake bends the sheet along the marked line to a pre-programmed angle. Workers use a digital measuring device to make sure the first bend is accurate. If it is, they continue bending along the remainder of the lines, transforming the flat sheet into a multi-sided round pole. Now the pole moves to a welding station, where hydraulic rollers apply pressure from both sides. This forces the edges of the sheet together so that a welding head can fuse the seam with molten steel. At the same time, the head deposits a granular powder called flux, which prevents air from penetrating the weld and weakening it. Workers place the pole in a hydraulic press, so it doesn't warp as the seam weld cools and shrinks. Next, a computer-guided plasma machine cuts a connection plate out of thick steel. The machine also drills holes for the high-strength bolts needed to attach the plate to the traffic signal pole. Workers center the connection plate on support plates they've already welded to the pole. Then they weld everything in place. Next, workers weld a base plate to the bottom of the pole. It has holes for the anchor bolts, which are used for securing the traffic signal to the street. Workers inspect the welds with a testing device. It uses an electric current to magnetically draw colored powder into any defective area. The factory ships the finished poles to a galvanizing plant, where they're dipped in a series of wash tanks. The plant's tanks are deep enough to fully submerge the poles, so they can treat both the inner and outer surface at the same time. Now, the poles go into a vat of sulfuric acid. This bath dissolves the more stubborn contaminants that washing can't remove. The next tank contains a chemical that weakens the surface of the poles. This allows the galvanizing metal to penetrate the steel rather than sit on the surface. The final tank contains molten zinc. As the poles bathe in the 842-degree zinc, workers in fire protection suits skim the surface to remove iron oxide and ash that floats to the top. This keeps the freshly galvanized surface clean, as the poles are hoisted out of the tank and set aside to cool.